All right, so now we're at basically the last few chapter challenges of the home unit. So we're going to go through the last few and talk a little bit about the end of the unit challenge. So first, activity 6, they have to now add insulation to the universal dwelling. All right, they have this question about attics being hot on a summer day versus, what are they like on a cold winter day? Something to get them thinking, as usual, to get them engaged. And you could bring this back to what they learned about convection. All right. And there's a really nice Eureka Science video. If you remember in one of my previous screencasts, I introduced this resource. And these Eureka Science videos, number 27, actually has an example of, convection and heat rising up through a home. So something you might want to show them as you talk about it. And there's some good information about heat loss in homes found on the internet, and it breaks it down into percentage wise. And this is going to help them think about this activity, because in this activity, they have students try insulating the attic first, the roof, I should say, of their home first, and then they collect heat transfer data. And then they try it again with insulating the walls and collect heat transfer data. So that's one way to go about it. What I like to often do is I might have the students, if I want to save some time, instead of doing this twice with insulating the attic and insulating the walls, I might have them actually just insulate their home in general, especially if we have a conversation about, the loss of heat through a home and how heat will rise through convection and leave through the roof. I can have students actually, in just one activity, insulate their homes, both the walls and the roof, but I allow them to pick a material. There's some possible materials you can bring in or have students bring in to insulate their model, their universal dwelling. So there's a lot of different ideas. You probably even think of some other things you might be able to find and have them try out. And basically, you have groups compare data and relate this back to the standard 3.4, mass and specific heat, talking about the thickness and how that affected the heat transfer or lack of heat transfer, and the specific heat, the differences in the materials, which do they think had a higher or lower specific heat based on their results. Okay, and then they could start answering these questions after and what they think. I usually do the first 5. I don't often have them research the R values or go and to a home center and do the R values. I usually don't have them do that. Just have them thinking about, basically based on the standards, the type of material, the thickness of material, the placement of the material, all related to heat transfer. And then for preparing for tomorrow, number 7, if you sign that for homework, they'll be ready for the next activity, which would be 1.7. So using that data where they're going to measure the windows in their home and then measure the walls, and they're going to find a window area to wall surface area ratio. And you might have to explain to your students what a ratio is. Some may not be familiar with that concept. Basically just dividing window area by wall area. All right, and this will give them something to go on with how many windows they're going to add to their home. And if they have difficulty with this, you don't really need to stress it that much. It's not like they're going to be tested on this ratio. It's just kind of give them a guiding point. But if that's difficult for them, just have them go ahead and start putting the windows in their home. And what I like to talk about with students is, the role of windows in the heat versus cooling phase. And that really gets them to think about, should they have windows that are able to close, during the cooling phase and open during the heating phase, understanding that there's quite a bit of heat loss through these windows once they add them. So how could they prevent that? So a little extra design scenario for them to think about for this activity of 1.7. So again, if the ratio is difficult for them to understand and apply to their design, just have them go ahead and, add some windows and, do the experiment, collect the data. Again, having them think about how can they improve upon this, perhaps having closable windows or flaps or something that will help these windows be effective during heating, but also to prevent heat loss during the cooling phase. Okay, so they go through that, and you could begin to review a bit about the different ways heat transferred into their home and the role the windows help play in this and their insulating material. Kind of start wrapping this up because we're going to be moving forward to the actual challenge where they're going to be presenting their universal dwelling and what they learned through this. So I found this really cool visual online, and it's very applicable to what they did. So a nice little review there you could present to students. And the reason I'm saying we're going forward here to the activities because most people skip activity 1.8. Okay. Actually, if you look back at your guided pacing guide, it mentions that you can skip this in light of, more review. And I typically skip this because, finding the latitude and all the stuff that this asks you to do is not something the students really need to know or apply, as they take their test in and go forward or even relate to the standards. So I skip this activity and we just move forward right to the actual challenge. Okay, so you skip this. You could have a discussion on it. I mean, it is interesting and it is relevant to them to know, how the angle of that heat affects, how much, heat is transferred. You could talk about the tilt of the Earth's axis and how that affects seasons and all that stuff. So it is relevant, but it's just not something that you really need to go into all the detail that it asks you to do in that. And your time's probably served better elsewhere. So I like to get right into the chapter challenge instead. And, this is their final presentation. Now, the pacing guide says this will take you, like 3 class periods to prep for. But I find that since we've been going right along, working on their universal dwelling the whole time, you're not going to really need the 2 to 3 days of prep time. Probably just one day for them to really get together and talk as a group how they're going to present the information, make sure their universal dwelling's ready for it. So, have them present. Now, depending on the number of groups, that may or may not take a full class. I mean, refer them back to the rubric and make sure they have everything, all the information they need to present about this. Stress that they need to relate the concepts we learned about heat transfer. But basically, you want to follow this up and supplement with a further review of the heat concepts, the standards that we covered. Few ways you could do that. One way I like to do is a Jeopardy review game. And as I showed you before, Super Teacher Tools has an online Jeopardy review game maker, or you could go online and find templates as well that you like a PowerPoint template that you could use. Because I always like to follow up their presentation the next day or even the day after. If I take a day for review, I like to follow up with a traditional assessment, just a regular quiz or test based on the standards, the heat transfer standards 3.1 through 3.4, because unfortunately testing is still a big part of our students' lives right now. So I like to pull some questions. Again, the Weebly has the link, but you can pull questions off the MCAS and give them a standard test to review as well. So I like to do that.